What's going on, party people? We're here. I just wanted to walk you through one of the more recent projects that I've been working on. This is the Ryoturia, and it's basically a 3D synthesizer piano. You may have noticed this 3D model in my previous animations. I've done a lot of like motion design animation stuff with this one, basically like using my MIDI to keyframe plugin in Blender to take like real music and then like play the keys and stuff. But all that's pre-rendered inside of Blender. So I wanted to actually like take this to the web and have a more live, interactive, like kind of like thing to work with. And I was like, why not let everybody else use it? You know, that'd be kind of cool. So here we are. I made it. We exported the 3D model as a GLTF file, and I was able to import it into basically ThreeJS through React 3 Fiber, because I'm using ReactJS as my framework. And yeah, I'll walk you through some of the cool stuff here. I can play the piano. You can kind of hear that. These are actually custom samples that I've actually recorded from Ryoturia Analog Lab, which is basically like another synthesizer type app that they have a bunch of different presets and stuff for pianos and different instruments. And then if I come up to the drum pads, I basically went and I recorded a drum pad from Analog Lab as well. So you can kind of get maybe a beat going. I don't know, something. But yeah, you can also click it. I'm using the keyboard right now and just pressing some keys like Z through like B, and then I have them spread out on top for the other one. But you can just click them. Or if you're on your phone, you can just touch it. Same effect. Boop, boop, boop. As you can see, it's kind of like the same effect that I was getting in Blender, where the keys light up blue, and then I also set the emission to basically be blue as well and light up. So you get a little bit of that glow action. And then I'm using a little bit of post-processing on the scene to kind of like give it some extra like oomph, some extra glow. Bloom, as they call it. But here I have a couple of different views that you can like scroll through, so you can kind of like appreciate the model. And as you can see in the background, we have a kind of like waveform, not exactly a waveform, that shows, and it acts as like a visualizer for our playback. And that waveform is basically based off of FFT data, which is kind of like a frequency of the music. So you can even see here, as I press notes, you'll see that the thing progresses like down, literally like we're on a bar of music. And it comes back. So it kind of represents a little bit of the frequency that we're playing. So you can even see when I'm doing multiple notes, it reflects like multiple of those arches. It's I thought it'd be a nice little visualization for this type of thing, instead of just using like an audio waveform or something that you normally see. I also have a bit of control over the app. I can lower the volume here so it's not as intense for you all and stuff like that. But you can also control some of the sampler here. Basically we use ToneJS under the hood. You can also change things like the ASDR or the attack, decay, release. So you can play with these a little bit. But yeah. Let's take a look at some of the code real quick. So like I mentioned, I basically brought a model in from Blender, imported a GLTF, and I used the CLI called GLTF GSX, and I basically just brought it in like that. It basically reads the GLTF file, which is, if you can open up a GLTF file inside of your text reader and stuff and see what it contains, and it contains the information about your scene. So what that CLI kind of does is it goes through and it picks out all the particular like objects that that scene may contain, as well as the associated materials with the objects, and then it assembles all that into kind of like a, you know, structure that you're more familiar with, like an HTML-like structure, with some of my custom components sprinkled in here. But that's where I started, and then see here that we've got things like animated piano keys. Basically what I do here is I have the model, the 3D model of the actual piano, one component. So that's kind of like isolated here. And then each piano key, since they all need to be animated, created a kind of custom component that wraps all that logic. And then I can just kind of dump in all the different actual piano keys. So it's more dynamic in that sense. And then you'll notice here, one of the little tips and tricks I can offer you, clone the material because if you don't actually clone the material, all these objects kind of share the same white or black piano key material. So if I make one pressed and like blue or whatever, it'll make all of them blue. So you have to make all these like unique materials. Ideally, I would throw this into a ref or something up top, but yeah, whatever. The magic happens in the actual Ryoturia component, where I have an input store that's basically just a Zeus stand store that I have just an input map of all the different keys. You can see just every single key you can imagine, and every octave kind of, we have like a true or false statement for it. So we know that when it's pressed or not. And you can see here, I even do some nice TypeScript magic to be able to do black notes, white notes, combine them together, combine them with the octave. So I basically just have one type here that has all the different notes. Pretty neat little trick. This one was actually pretty cool. But if I go back to where I was, we can basically see that I use that input and then I pass it down into the piano. And for the piano itself, we care about the fourth octave, which is like one of the more standard ones, and then, or like the middle one or whatever. And then for the drum pad, I just assigned all the drum key stuff to the next octave over. So you can see that that's just kind of assigned here. And we pass all those props down to the actual model itself, which, like you saw, sprinkles all of those things down to the piano keys themselves. And then the piano key, this is kind of where the magic happens. You can see we basically have to rotate it to a certain extent. We have to light it up and make it glow, and we also have to change the color of it. So this piano key, you can see it cares if it's pressed, cares if it's black, it cares if it's a drum pad or not, because if you notice with the drum pads, we're actually going up and down, and we're not actually rotating, so that'll change stuff. Basically with this one, we use the use frame animation loop that React 3 Fiber offers us. This basically runs this function every single frame, or like as much as possible, basically. And then inside of this, we can basically go and say, if we have the mesh, this saves like basically the current position, or like the original position, because we have to do like math based off of that. We basically animate, and we animate based off of the press state. And we're using an easing function here that comes from the math library, which is kind of like another, and it offers you functions like this, which basically do easing, damping, just interpolation between values, basically. So I basically put in, this is the position of the mesh. I want to change the Y position of it, and I want to change it based off of when it's pressed or not. So when it's pressed, I need it to go down a certain distance, or if not, I need it to go back to the original position. And it'll do that based off of a certain time that I give it, and I also provide a delta so that it just does it, interpolates it based off of like the frame rate or whatever. I do that for the drum pad, and I move it up and down, as you can see, based off of the position and the Y. Or if I need to rotate it, I'm rotating the X here. And then here is where we change the color. If it's pressed, I basically go and I create a kind of like my own interpolation here. Because I actually tried to use the easing function that math provided for the colors. I think I literally left it here. Yeah, this just doesn't work for me. So I literally had to basically reproduce what this function does and do it manually. So that's what I do here. I basically created a ref that stores the delta. I increment it, and then I basically go and change the colors of each thing, R, G, and B of the material. And we also do the emissive factor here, and we change the emissive color to the right color, and we change it to glow. We basically go from 0, which is no glow, to 3, and we lerp between all of that kind of stuff, which is another like animation function that interpolates values basically. And also, like I mentioned, we have the on-click here, and I have like a little on-clicky thing, and it hooks up to the store that I mentioned earlier, where we can set the input. And you can see like we can just set the input from this object, like it connects it to just multiple different places. Piano, all kind of like here. We can see similar stuff with the gamepad. Like if I go and I grab my DualSense right now and I play with it, and now you can see I can press keys. Oops, sorry, there you go. And that's basically mapped up using this hook that I created, that it basically just uses the web gamepad API. Goes and it loops, I'll show you here in a second. Scan gamepads is kind of where the magic happens. So we have to basically do everything inside of a request animation frame, which is like the use frame loop that we were doing before. Like this happens every single frame. And every single frame we scan for gamepads. And when we're scanning for the gamepad, we basically grab the gamepad, we grab the data off of it, and then we sync that data to the store. And that happens up here, where we basically set the input, set multi-input, but it's basically input, and we use it in the import store. Same kind of concept, we map keys here, so all the keys on a gamepad are mapped like 0, 1, 2, 3, 4, you can see here. That's literally like all the face buttons, that's like 0, 1, 2, 3, 4, and stuff like that. So you map those to different keys, and I basically, you can see here, I use that map against like what gamepad is being detected or something. Yeah, something. It's here. You can see it. If you know code, you know code. You can like see it. This is also available open source up on GitHub if you want to like read into any of this a little longer and linger more than I maybe am. Yeah, like I mentioned, like the keyboard, it just maps like Z through M, boom, whatever, like all here, just map. It hooks up to the input store, you set the input, all connects to the same place, and it just kind of works. The music, maybe what you're kind of interested in. I have a music component that I basically created, and this music component, it picks up what type of kind of synthesizer you want. Basically ToneJS, the library that I use, they have a polysynth, which is kind of like their own sampler for like synthesizer stuff. And then these are different samplers that I've created. One is basically just a piano, and the other one is, like I mentioned, piano and drums. So it's mixed. But I can go into either of those samplers, like the mix sampler, and you can see that me creating a sampler is just using my base synth component that I created. And I provide a particular configuration that basically is just the same config you would pass to ToneJS. So I go inside of this base synth here, and I can show you that this is kind of where the magic happens. I have the input store that I can check for all the input stuff. And then I also have an app store that I created. And this keeps track of things like whether the thing's muted or not, and also the volume and like other stuff, and just anything that I need related to like the music and the synth controls. But you can see that we basically have a use effect here. This is where we create the synthesizer itself. We basically have to create all the different attachments to the synthesizer first. So we have to keep track of the FFT data. That is the visualizer that you see in the back there. I also have waveform data if I wanted to actually keep track of the audio waveform. And then we also set up a pitch shift component to be able to alter and shift the pitch of a particular octave. And then you see here I create the synth. This kind of, if you've seen the ToneJS documentation, should look very similar. And we store that synth inside of a React ref so that I can keep track of it later. Then obviously when the component dismounts, we want to be able to like release and destroy like anything that is associated with that, so we don't keep any like memory leaky data around. And then in this use effect, basically check when the input changes, and then based off of when the input changes, we play notes using ToneJS basically. And we use the synth, and we trigger an attack. And then we basically trigger an attack when something's pressed, and we trigger a release when it's turned off. So that allows us to actually hold the key down and keep it pressed and then let it go. So it doesn't like just press it and press it a little bit. It's like press hold. But yeah, that's the synth, man. It's pretty simple. Hope you appreciated this. I'm a little over. I could probably edit it down. Thank you all for watching. Check out this little app. You can head over to ryoturia.netlify.app, or you can head over to github.com/whoisryosuke/Ryoturia. Sorry, it's like not helping me. And I know the URL. But yeah, head over here. If you want to see the source code, you can spin it up yourself locally if you want, or you can just head over to Netlify and just play with it. Boop, 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 boop. But yeah, enjoy. Take care. Stay curious.